Section 1.5 continued, Part 2, talking about compound inequalities. If you are in English class and you talk about a compound sentence, it's when you take two complete sentences and combine them with the words and or some sort of conjunction. A compound inequality is two inequalities joined with the word and or. I have a typo. This should be the word and or the word or. So example 5, solving an and inequality. It says, what is the solution of a divided by 2 is less than 3 and negative 3a plus 5 is less than 8? And then they want us to graph the solution on the same number line. So an and inequality means that the solution to a, typically 99% of the time, the value of a is in between two endpoints. And means it includes, it's all together. So that means it's going to be somewhere in between two endpoints. So we're going to go ahead and solve each of these individually and then graph the solution on a single number line. So a divided by 2 is less than 3. To get a by itself, we're going to multiply by 2 to each side. That means a is going to be less than 6. We'll hold tight for a moment and solve out the other one and then see what that's going to look like. So we have a negative 3a plus 5 is less than 8. So if we go about solving that, we're going to subtract 5. We end up with a negative 3a is less than 3. And dividing by a negative 3, if you remember from the prior lesson, anytime you multiply or divide by a negative value, you have to switch your inequality sign. So that's going to give us a is greater than negative 1. So if I were to go to my number line and kind of look at what I have in terms of my values for a, let's see, we're going to start at negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. That should help us fit all of our numbers on that number line. So let's see. We have a was less than 6. So if I go to 6, a is less than 6. So we have an open circle at 6. Less than means I'm going to start shading to the less than portion of it, which means it's going to start shading off to the left. If I have a is greater than a negative 1, I go to my negative 1. And again, I have just an open circle because I don't have or equals to. And if a is greater than negative 1, that means I'm going to start coloring towards the greater than or to the right side. And so what happens is these two pieces overlap each other to tell us what all the values of a would be that would make both of those inequalities true. That means that I'd have a negative 1 is less than a, which is less than a 6. So this would be your final inequality and your final graph. A falls between. If you want to give yourself a little, this is between. A is between those two endpoints, non-inclusive. If we were to look at example 6, solving an or inequality, we're going to follow the same procedure, except we're going to have a slightly different graph. Now, an or would mean more or less like you are going to a less than or you're going to a greater than. So instead of those two shaded regions kind of meeting in the middle, they're going to shoot out to the ends. That's typically what an or problem looks like. Every once in a while, the book companies get carried away and they give you one that does not quite match our theory. All right, so what is the solution of? We have a 5 minus 2m is greater than or equal to 21. Then we have the word or, 4m minus 1 is greater than or equal to negative 21, and we'll graph our solution. So let's start with that first inequality. If we solve that down, we would have to get rid of that 5 by subtracting 5. We're left with a negative 2m is greater than or equal to 16. Dividing by a negative 2, when we divide by a negative, that means we end up switching our inequality sign, and 16 divided by a negative 2 gives me a negative 8. I have the word or. Let's solve the next one out. If I need to get m all by itself, we're going to add 1. We'd have 4m is greater than or equal to a negative 20. Dividing by a positive 4 means we're going to have m is greater than or equal to negative 5. I did not need to flip my inequality sign because I did not divide by a negative. The number on the bottom is what you're checking for the sign if that had to switch. So now if we go and take this to our graph, let's see what we got. Number-wise, we have negative 8 and negative 5. So I'm going to go down here and go negative 10, skip 1, go negative 8, skip 1, negative 6, skip 1, negative 4, -2, and 0, since we're only dealing with some negatives. So if m is less than or equal to a -8, when I go to my -8, I'm going to have a solid circle at -8 because it says it's or equal to. And that tells us m is less than. Less than means I'm going off to the left side, which means I'm going to go all the way down to this arrow and create a larger arrowhead. And then we have the m is greater than or equal to a -5. So -4, -6, -5 is right in the middle. Again, this one's also an or equal to, so I get to shade that piece in. And then m is greater than means that I'm going to shade off to that right-hand side. M is greater than that value. My arrow is not so pretty. It's all good though. And that's an and an or, solving your compound inequalities.